the octet rule. Turns out not everything, fits perfectly as we might imagine, okay? We are going to have a couple nice boxes for our exceptions. So let's look at these. Number one, electron deficient molecules. And number two, that is molecules that don't have enough electrons. And number two, molecules that have too many electrons, okay? So let's look at how those work out. So for example, one example of electron deficient molecules is nitric oxide. Nitric oxide is a very cool molecule. It turns out it's very important for blood pressure, and it doesn't have a right number of electrons. No matter how many electrons we do here, right? Because nitrogen comes in with 5 valence electrons, oxygen comes in with 6 because they're in group 5 and group 6. Well, that's only 11 electrons. We can't. There's no way to make a Lewis structure that has got each octet filled. So we just do the best we can. 2, 4, 6, 7. 2, 4, 6, 8, right? So that's good. That's almost good. Let me draw a little shaky check mark, okay? Not quite good, but it's close enough, and that's the best we can get. So this is an electron deficient molecule. We cannot draw a Lewis structure that has got completed octets, and so this is an example of an exception. Another example of exception are when we have central atoms that are only surrounded by 4 or 6 electrons. So beryllium and boron, this is probably the most common one. So let me go here. Boron is in group 3. Hydrogen is in group 1. Another hydrogen group 1. Another hydrogen group 1, right? So that's only 7 electrons total, or rather 6 electrons total. We can't get 8. It does only have 6 total for BH3, right? So here's 2, and there's 6, and that is our Lewis structure. It turns out the hydrogen's okay, it has 2 electrons in its outer shell, and since its outer shell only has a capacity for 2 electrons, that's solid. But boron is in group 2, or rather I should say period 2. It has a capacity for 8, but it only has 6 in its outer shell, and it turns out it's just fine. All right? So this is an exception to the octet rule, and we would do similar things with beryllium, which is right next to it in the periodic table. This is an example of octet rule exceptions because we don't have enough electrons. They are electron deficient molecules. All right, so let me skip that slide. I left some space for me to do that, but I did in the previous slide. Let's go here and say elements in the second period can only accommodate 8 electrons, right? So if we have too many electrons, then we can't do anything with stuff in the second period. It won't work. But in the third period, n is equal to 3, we actually have access to d orbitals, right? So S has a capacity for 2, P has a capacity for 6, D actually has a capacity for 10. So normally S and P's are the only ones that are filled, and that's why we have octet. But we can have some orbitals in D. In other words, we can actually fit more. So sometimes a central atom may have 10 or 12 electrons. So a decat rule or dodecat rule, right? We don't have a dodecat rule. We still call it the octet rule. And we simply say if it has 12 electrons, it's an exception. Hypervalent molecules are molecules with a central atom surrounded by more than 8 electrons. The most common violation. This is the most common violation to the octet rule. Now, these 3 atoms are in the period 3, and they all 3 sometimes will show up with more than 8 electrons. Here are some in group 4, or rather period 4. Excuse me, and here are some in period 5 that show up with more than 8 electrons. So an example of that would be sulfur, hexafluoride, or phosphorus pentachloride, right? Both of these have too many electrons from outer shell. They're called hypervalent. Can you see? Look at all those electrons are in sulfur's outer shell. 2, 4, 6, 8, 10, 12. It has 12 in its outer shell. Therefore, it's an octet exception, of course, right? And this one has 2, 4, 6, 8, 10 in its outer shell. Also an octet exception. All right, so again, octet exceptions happen with electron deficient and where's my writing? Hypervalent systems, okay? These are octet exceptions. Watch out for them. You'll recognize them. They get to be pretty familiar.